Now we're going to take the graph of the cubic function. A cubic function is a polynomial in this form where the highest power of x is 3. For example, fx is equal to 5x cubed minus 2x squared plus 2. This is a cubic function where the highest power of x is 3. Let's start by the simple cubic function where fx is equal to ax cubed. For this function, the graph of this function has this shape and it has a point of symmetry at the origin point. The y-axis and the x-axis are the two axes of symmetry of the graph. The graph has two parts. Draw the first part in the first quadrant and the second part in the third quadrant. If A is negative, the graph will be reflected across the x-axis to be in this shape or like this. So the two parts of the graph will be in the second quadrant and the fourth quadrant. This curve goes forever in both sides of the x-axis. So the domain is all real numbers. Similarly, the curve goes forever in both directions of the y-axis. So the range is also all real numbers. For the simplest form of the cubic function, where fx is equal to ax cubed or negative ax cubed, the graph is symmetric about the origin point, so the function is an odd function. Now, let's translate the curve. Let's start by the vertical translation. This is the original curve, where the point of symmetry lies at the origin point. Let's translate the curve up and down along the y-axis. The new equation will be fx is equal to ax cubed plus c. So for a vertical translation or for the curve in the point of symmetry, just add a constant term to the cubic term. So for fx equal to ax cubed plus c, the point of symmetry will be on the y-axis and it will be shifted c units up or down according to the sign of c. And the coordinates of the point of symmetry is 0 and c. For example, if fx is equal to 2x cubed plus 1, the plus 1 means that we have a vertical translation and it represents the y value of the new point of symmetry, which is 0 and 1. Another example, if fx is equal to 1 over 2x cubed minus 3, the new vertical translation of the curve and of the point of symmetry is y equal to negative 3, so the new point of symmetry will be at 0 and negative 3. Now a horizontal translation for the cubic function. If we move or translate the curve horizontally along the x-axis, the new point of symmetry will be at this value or at b and 0. So if fx is equal to a times x minus b all cubed, or if we add a number under the cubic power inside the bracket, this value represents the horizontal translation or the x value of the new point of symmetry, but after changing its sign. So the new point of symmetry will be at positive b and 0. For example, fx is equal to 5 times x minus 3 all cubed. The value inside the bracket will be for the horizontal translation or for the new x value of the point of symmetry. The new point of symmetry will be at 3 and 0. Another example, if fx is equal to 1 over 4 times x plus 2 all cubed, so the x value added inside the bracket is for the x value of the new point of symmetry. After changing its sign, we have plus 2, so the point of symmetry will be at negative 2 and 0. And the value and the sign of A will not affect the coordinates of the point of symmetry. To graph the curve, just plot the new point of symmetry, draw the two new vertical and horizontal axes, passing through the point of symmetry, graph the first part of the curve in this way in the first quadrant and the second part of the curve in the third quadrant if A is positive. And of course, if A is negative, the two parts of the curve will be in the second and fourth quadrant. if the horizontal translation and the vertical translation are combined in the same function, the graph will have both translation. So if fx is equal to a times x minus b to the power 3 plus c, the number added outside the bracket represents the vertical translation or the y value of the point of symmetry, while the b with opposite sign or the number added inside the bracket is for the horizontal translation or the x value of the point of symmetry. So the coordinates of the point of symmetry is b for x and c for y. And the graph will be translated b units horizontally and c units vertically. And to graph the function, we just need to plot the new point of symmetry at b and c, then sketch the vertical and horizontal lines of symmetry that passes through the point of symmetry. Then you sketch the first part of the graph in the first quadrant and the second part of the graph in the third quadrant, like this. For example, if fx is equal to 2 times x minus 3 all to the power 3 plus 1, so this is the y value of the new point of symmetry, and keep its sign. So this is the y value, 1. The number inside the bracket is for the x value or the horizontal translation, but change its sign. So negative 3 will be 3 for x and 1 for y, and this is the coordinates of the new point of symmetry. Another example, if fx is equal to 1 over 2 times x plus 3 all to the power 3 plus 2, so the number inside brackets is for x, but change its sign to be negative 3, and so this is for x, and the number outside brackets is for y, and keep its sign, and the coordinates of the new point of symmetry is at negative 3 for x and 2 for y. If a is positive, the graph will lie in the first and third quadrant. Similarly, if a is negative, the graph will be at the second and fourth quadrant. And of course, the coordinates of the point of symmetry are not affected by the sign or the value of a.